Well, hello everybody, and welcome to the next installment in your program of events, and that's numeracy. And I know that all of us have an opinion about numeracy. Some of us are really good at maths and really enjoy it, and others do not like it at all. And I think part of that enjoyment comes from what we like as students ourselves. When we were at school, did we enjoy maths, or did we think it was our worst subject ever? I know for me, I really enjoyed it, and the reason why I enjoyed it is because I had success. And the more success I had, the more I enjoyed it, and it just set me up for a pattern of enjoying learning. I'm quite sure though that if I didn't like maths, I would have had to endure it, and would have been like me enduring a gymnastics lesson. I would have hated it. And some of the research is actually backing up my own experience, in that if you have success at an early age in mathematics, that success will continue to improve our enjoyment of learning, and will give us a confidence in the activities that we use with our mathematic computations, and the solutions that we need to use maths with, we will feel very confident. I think that as a Christian school, we need to be sharing with the children why maths is so important and so vital, not only to everyday life and to the meaning of life, but the very fact that God loves maths. He actually designed it. And when we look at our world, we can see patterns and order and neatness in the way God designed creation. I have talked to many excited, passionate maths teachers, and all of them, without a doubt, talk about our Creator God, what a great designer He is. One of the teachers that we used to have at Pacific Hills, who was a maths head of department, was Mrs. Narelle Bowen. And she used to walk around the school telling every child, "Isn't maths wonderful?" And I've actually got one of her papers that she put out years ago. And this is what she says. She says, God designed a universe along rational principles that humans can explore and discover. These physical laws, the laws of creation, inbuilt into a created order, are expressed in mathematical descriptions. So what she's saying is that God gave humans the creation mandate to be stewards of creation and to use their gifts to build culture where humans can flourish to God's way. And that maths is applied to all other subject areas. So that's what Narelle says. Another person who's quite well known in Christian Education National is Pete Martle, and he puts out workshops in Does God Love Maths? And I love it because he says, I'll quote what he has to say. He's quoting Colossians 1:15-20, and he says, "The Son is the image of the invisible God, the firstborn over all creation, for in him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things have been created through him and for him. He is before all things, and in him all things hold together. He is the head of the body, the church. He is the beginning and the firstborn from among the dead, so that in everything he might have the supremacy. For God was pleased to have all his fullness dwell in him, and through him to reconcile to himself all things, whether the things on earth or things in heaven, by making peace through his blood shed on the cross." And great scientists and great mathematicians have always come up with the revelation that God is the great designer, the great designer. But as teachers, we have the great authority in the classroom to either bring passion to our lessons or to bring endurance. And I think that one of the important things we need to do is to explain to children that God created mathematics and He is the great designer. And I love the fact that we can use mathematics to explore what a great designer God is. Some of you might have heard of Fibonacci numbers. And you're going to say, oh, Fibonacci numbers, Tina, why are they important? Well, because Fibonacci numbers actually are what we see in creation. So if I was to tell you that in a daisy there are 13 petals and 13 is a Fibonacci number, you'd be astounded. When we look at all of the petals in other flowers and we were to count them, we'd see it's a Fibonacci number. Fibonacci numbers can be seen as a sequence in sunflowers' heads, and the way that God has patterned that. We can see Fibonacci numbers in seashells and rectangles and golden rectangles in seashells. It's amazing when you look at the way God's designed the universe, and you can see again Fibonacci numbers. So we see Fibonacci numbers in shells, in hurricanes, in galaxies, in pine cones, in cauliflowers, and you know there's even a Fibonacci sequence in music. There are 13 keys, 8 are white and 5 are black. And you guessed it, 13, 8 and 5 are Fibonacci numbers. So are you interested in Fibonacci numbers? Do they make sense to you? Fibonacci numbers are numbers that you keep on adding 2 to, and then you add the number before it, and so there's a sequence of numbers. And I can tell you that the list of Fibonacci numbers is this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1,597, 2,584, 4,181, and the list goes on. Interested? Well, I think it's fascinating, and I want you to try and show the children how fascinating maths is. But I think maths has to have some relevance. I think we have to just not teach maths for the sake of teaching maths, and not just say this is what we're learning today without any context to it. Because maths is a real life subject. Maths is in everyday life. And I think as parents, we are already showing and teaching our children maths in our everyday life. The important thing for me is that maths is taught very early. We see maths in the home, we see maths in kindergarten lessons, we see maths all around us. And giving the children these real life experiences and showing relevance and meaning is what's going to keep them motivated. Nobody wants to see an algebraic equation written on a board and say, here, solve this. Or today, we're going to do quadratic equations. Here it is, solve this. There has to be some meaning and relevance for maths to be motivating. And I think that in a Christian school, we can see maths relevance in all other subject areas as well. And once the children see that it is in every other subject, we're then giving them a platform for engagement. I will now refer refer to our textbook. So the textbook for today are obviously the same, Common Sense Methods. And using my text today is chapter, let me just see, chapter 13. And it's called Numeracy and Basic Mathematical Skills. And I'll read from the very first paragraph. In this age of information and communication technology, the importance of numeracy has increased, not decreased, and now ranks alongside literacy in importance. Literacy and numeracy are recognised as vital foundations for children's overall achievement at school, and both areas of competence are also crucial for transition into further education, training and employment. And when we look at our developing countries, America and Australia both have students who at the age of 15 are failing maths. And we've got to ask our question, why? Why are children failing at maths? What happens? Why do they then start failing? If they've all been to school for 10 years and all of a sudden they're failing maths. This failure, I believe, would start at an early age, and I think sometimes in schools we can give too much emphasis to reading at the detriment of mathematics, and there has to be a balance. We have to, sure, teach reading, it's pivotal for life, but so is mathematics. It has equal importance. And you can't do maths unless you can read. We understand that. But let's not put too much emphasis. I can remember many years ago when I was a primary school teacher, the teachers would tell me if they were going to miss any lessons because they were short on time, they would always miss a mathematics lesson because they thought they could catch it up the next day. But what we've come to see through research now is that mathematics has to be taught daily. We've got to keep these skills being practiced on a daily basis, because if we don't keep these skills being used, we will lose them. It's a bit like driving a car. If you don't drive your car very much, you're going to lose skills in driving your car and lose your confidence in driving if you only drive very occasionally. So I'd like to encourage you to remember the importance of daily routines in mathematics. You might have noticed, what is the big emphasis on NAPLAN, reading and mathematics? Big emphasis, because authorities are recognising the importance of reading and maths. And we, as some schools in some areas, have been given huge grants of money in the area of literacy and numeracy, so that we can get the children's skills up to a benchmark that is going to make them functionally literate and functionally numerate for their cohort. So how did this happen, that there was a decline in the students' mathematical ability in countries such as Australia and America, when we also know that Asian countries such as Japan and Korea and China and India have always had such good results in their PISA results in the area of mathematics. And I think the reason there is that those countries did not go into the constructivism of the 1980s. Now, constructivism says that we can discover maths concepts if we just give the children time and resources and give them guided discovery. Then they will discover computations, and they will discover maths in their world, and they will discover how to compute. that actually didn't go down too well. And I think very well-meaning teachers used that approach. Certainly in the 1980s, this was an approach that was put forward when I was a young teacher. And I think that discovery learning is really good for students who have a natural aptitude, but students who need help, they just played with the concrete material and didn't see the connections. So let's think what then is needed if the children are not making the connections. Well, we go back to what we've learned as well in teaching, is that direct instruction is essential for children with learning difficulties. I think that it's a bit like swimming lessons. If you throw children in the water, some of them will try and swim, and they may swim, but most children learn to swim by having a swimming teacher who teaches them the skills of swimming, and then they put the skills together and they learn how to swim. And it's a little bit like that with mathematics. Mathematics is a series of steps in computations, and we have to learn each step in a sequence, in a hierarchy, to actually perform the task, and in swimming, to learn to swim. If you don't know any of the steps in a swimming sequence, you will not be able to swim. There'll be a gap in your learning. And so it is with mathematics. We have to have each of the steps in sequence to be able to perform a mathematical task. I think also in swimming, say for example, you were never taught to blow bubbles. Well, then you wouldn't be able to breathe underwater. And the same with maths. If you're not a very good counter, and you don't understand counting, then, or counting on or counting backwards, then addition and subtraction is a very difficult skill to acquire. If you don't understand repeated addition, you won't understand multiplication. And if you don't understand repeated subtraction, you won't understand division. So all of those things are skills. And if we get children who don't understand each of those steps, then they're not going to be able to make the sequence and perform the task. So that's why direct instruction is really important. I think that we can learn from countries overseas. We can learn that discovery learning is great for some children, but most children learn by direct instruction, by being given how to perform a task. But there has to be some kind of relevance around it. So if I'm getting a task of adding numbers together, why not make it a real life problem so the children can see the meaning and the relevance rather than just a computation? And that's what's really important, is that when we're teaching maths, the children will say, whether they say it verbally or internally, why am I doing this? What possible use is of this skill in my life? And I can tell you that once you give them the context for it, you have more engagement. So how do we teach maths? Do we teach it individually, or do we teach it as a whole class? Well, the research seems to think that we teach it as a whole class, and that we shouldn't take away from students with learning difficulties any of the curriculum content that most children in the class are attending to. So yes, we will give them the curriculum, but we will make adjustments along the way for them. Some of the adjustments may be that we have to teach them a skill individually. Some of the adjustments may be we give them less problems to solve. Some of the adjustments may be that we give them concrete materials to help them do the problem. But what we don't do is withdraw them out of the class, because then they have a gap. And that's a really fine line. Any remediation that we need to do with students with learning difficulties should be done outside of the classroom, but not at the same time that the maths is going on. So most remedial programs will have to be after school, because by removing them, we've given them another task to do that they've missed out something else. Most things in the maths curriculum that are a problem is because the students haven't understood the process and have some gaps in their learning. We don't want to have more gaps. So yes, we'll do a whole class approach as well as an individual approach. I think that most children who have problems with maths, including their background, is that they have a tendency to think that, oh, maybe I don't need it. We often find that girls, particularly in years 9 or 10, do not do well in maths because they don't think it's culturally important, and that, maths is better for boys than girls. And that's not true. We know genetically as well as culturally that girls have the same aptitude for maths that boys have. So gender is not the issue in mathematics. What the main issue is that in the early stages, they've lost their confidence and hence their motivation. And then as they get more and more difficult maths, their anxiety grows, and therefore they then cannot attend to the level of the classroom, and they have high anxiety, and that impedes their learning. I think that for teachers, we can sometimes make too much use of a textbook, and that can impede the learning. We need to make our mathematics lessons relevant as much as possible in the natural environment and see links to other areas. But let me just read to you from page 149 about the major factors associated with learning difficulties in mathematics. So what are they? Well, insufficient or inappropriate instruction, students falling behind and becoming discouraged, little or no differentiation of learning activities or assessment tasks, too little structuring of activity-based tasks, teachers' use of complex language, students' weak reading skills, too little teaching devoted to ensuring students achieve conceptual understanding. And in terms of specific weaknesses in basic number skills, abstract symbols may have been introduced too early in the absence of concrete or real-life materials. Students' gaps of simple relationships in numbers to 20 may not be fully developed before larger numbers involving complications of place value are introduced. Students may misunderstand the relationship between rational and whole numbers, thinking that 1/4 is larger than 1/2 because 4 is larger than 2. And too little time is spent in developing automaticity with number facts, leading later to slowness and inaccuracy in calculations. So early intervention is really important, especially in the areas of number recognition, grouping, solving simple addition, subtraction. And the mastery of basic facts and development of sound number sense must be given high priority. Basic facts, number development, number sense. What does that mean? Well, let's have a look at the concrete materials in a few moments' time. But basic facts of numbers. Do the children know all the different combinations that make up 10? We have a decimal system. So 6 and 4, 10. 7 and 3, 10. 9 and 1, 10. 8 and 2, 10. Do the children know their 10 tables, their 10 adding tables? If you know that automatically, it makes life very easy. Do they have their 20 adding tables? Do they know that 12 and 8 makes 20? 13 and 7 makes 20. It makes life very easy if they can do things in their head. And I think too little emphasis has been placed on mental facts. When you have mental facts in your head, it makes the guesstimate, when you've got to guess what something might be, easier than having to do the computation. So in a moment, I want to speak about struggling mathematicians, but let's think about how we can engage our students in real life problems. What sort of problems do you think the students will be happy to tackle? I think that when you bring it back to the students' environment, whether it be a home environment, whether it be their community, then they will be more inclined to be involved in listening and engaging the lesson. I've always found that food and money are great motivators for students. Fractions are much easier if you're bringing in a block of chocolate or a baked cake or pieces of an orange. And I think that that kind of thing is important. And when we talk about money, I don't think we should be bringing in the plastic money. I think that's just so bad. I think we should bring in real money and start talking about what we can buy with money and what change to expect, so that the students, when they're shopping or giving over money. Another thing we've got to be very aware of now is the credit card, the EFTPOS. Do the students know whether or not that their money on their card is correct? Do they know that they're not being given the wrong total at the cash register? And so skills of today will be adding on to the skills of yesterday. Cash is not as relevant today as it once was. We're now having to look at digital money, which is a whole new ballgame. And I want to talk about that a little bit later in our next section. So I'll just pause now for maybe you might want to have some discussions about what I've just said. And I'll be back for our next session in a few moments.